This question is about varies directly. Varies directly. And it's talking about stopping distance of a car varies directly with the square of the car's velocity. First thing it asks is define the two variables. So starting right at the beginning, stopping distance of a car. I'm going to choose D. So D is stopping distance. And for defining the variables, remember I need some words and units. So a car moving at 30 miles per hour takes 52 feet. 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 Okay, back to the first sentence. The stopping distance of the car varies directly with the square of the car's velocity. I'm going to pick V for velocity. And the units for that, a car moving at 30 miles per hour. Miles per hour. State a variation statement using the variables. So going back to the first sentence, the stopping distance of the car, D, varies directly, so you know that's fish thingy, with the square of the velocity. So V squared. Find the equation. D equals, so I'm changing the fish symbol to an equal sign and putting in a K for a constant. V squared. And I'm inserting my numbers from the second sentence there. A car moving at 30 miles per hour, that's the velocity, 30 squared, equals, and the distance was 52 feet. So on my calculator, I am leaving the K where it is, and I'm going to be moving the 30 squared over to the other side. 30 squared is attached by multiplication, so I'm going to do the opposite, which is divide. 52 divided by 30 squared. And I'm coming up with a big long decimal. I'm going to round that 0.057777 off to decimal 058. We're not done yet because it says find the equation. So here's the equation. D equals constant 0.058 V squared. So all I did for the equation is I subbed in the number for the K, 0.058. Right, then it says, using your equation, find the stopping distance for a car traveling at 70. So my equation is D equals 0.058 times V squared, and the V this time is 70. So 70 squared, and so on my calculator, 0.058 times 70 squared. And I'm coming up with 284.2. And distance, that's going to be in feet. Okay, now I'm going to graph the equation. Graphing the equation. From the first sentence, we know that the stopping distance of a car is mentioned first, and it varies directly. And we know that varies directly also stands for depends on. So the dependent variable is stopping distance, so that's going to be D. So on my graph, this is going to be the D-axis. And on the graph, this is going to be the V-axis. And I have two sets of numbers to work with. The first set of numbers is the 30 miles per hour and 52 feet. And the second, so I'm going to set up a table of values just to put this together. So I've got car velocity as the independent variable and stopping distance as the dependent. And on this table of values, I've got for velocity 30 miles per hour, and the stopping distance was 52. And for the second one, the car was traveling at 70 miles per hour, and the stopping distance was 284.2. Okay, over to my graph. I need to set up the scale on the axes. For V, I'm going from 30 up to a biggest number of 70. So let's see, 10, 20, 30, 40, 60, 70. I'm going to go a scale like that. So this would be 70, 50, 30, 10. No wrinkles on the axis allowed. Got to start from 0. For distance, I've got a maximum of 284.2. Let's see, maybe I can go by 5s. 1, 2, 3, 4, 5. So that would be 100. 1, 2, 3, 4, 5. That would be 200. So I'm actually going by 20s. Okay, so for the first dot on the graph, we want to go 30 across and 52 up. So that's 24, 52 up there. And for the second dot, I've got 70 across and 284 up. So that's 220, 240, 260, 284, about there. This graph, so for any of these where it says square, cube, so I'm looking at the exponent. So any of those exponent graphs, they are all going to go through the 0, so 0, and they're going to be a curved line. So I'm going through the dots here for my curved line. And it's going to look something like that. What's the independent variable? Well, at the beginning of the question, the stopping distance of a car depends on, so that was dependent, so independent is going to be the velocity. So independent variable will be